I wanted to start by talking about interval notation today. Interval notation is just a way to write a set of numbers when you can't list all the numbers in a list. There's too many to make a list. This is kind of a shortcut way to write a set of numbers. So usually we start out with an inequality. So our inequality can have a less than or greater than sign. Usually in that case we are not including the endpoints. So on the number line, sometimes we draw an open circle, and when we use the interval notation, we use a parentheses or a round bracket. If it's less than or equal to or greater than or equal to, then the endpoints are included, and we used a closed circle sometimes on the number line, and when we draw the interval notation, we're going to use a square bracket. So let me give you a couple of examples. First, if we had the inequality x is less than or equal to -3, we could use a number line as a visual aid. So the number line is not the interval notation, it is just a tool to help us decide what the interval notation will be. Okay, and it's just for your scratch work, so it doesn't have to be precise. So here's our number line. I'm going to put -3 on it. If I want to write the set of numbers that are less than or equal to -3, I want to include the -3 because I have the equals bar, and everything less or smaller than -3, all the way down to the arrow. The arrows here represent the infinities. So the left side would be negative infinity, the right side would be positive infinity. And then to write the interval notation, we're going to consider the shaded area, and we're going to list the endpoints from left to right using the appropriate brackets around them and separating them by a comma. So to list the interval notation for this interval, we would start on the left here. The infinity sign always gets around parentheses because it's not an actual number that we can land on, right? It is more of an idea that the numbers are going on forever. So we're going from negative infinity up to -3, and the -3 here is included, so we're going to use the square bracket around it. And that's the basic idea. I want to give you a couple more examples. There are a couple different types of problems that you can see. Here's another one. Okay, so we could say I want to describe a set of all the numbers except for the number 4. So same thing, we can use a number line as a visual aid. So really 4 is the number of interest. We want to leave 4 out of our set. So this is where the open circle would be appropriate. So that shows that 4 is not in the set, but we could shade everywhere else on the number line to include all of the other numbers within the set of real numbers. And when we do this one, actually we end up having 2 parts to our interval notation. All the numbers on the left here represent any number smaller than 4, and all the numbers on the right here represent any number bigger than 4. Okay, and so basically we have 2 possible, we just can't let x be 4. So we have put 2 possible places where a number could be. And we're going to go from left to right again for both of these regions. And so we're going to go from negative infinity up to, now technically we're going up to 3.99999. To show that, we're going to write the 4 and use the round parentheses. That means I'm getting infinitely close to the number 4, but I'm not including the 4 itself. So I use the parentheses. On the other side, the exact same thing. From left to right, we are starting just after 4, 4.00001. Okay, infinitely close, but we are not including the 4, so we use a round parentheses. We're going to go all the way up to infinity. If our interval notation has more than one part, then we put the union symbol in the middle just to show that this set of numbers contains numbers smaller than 4 and also or it could contain also numbers bigger than 4. Okay, and the last example, this is a double inequality, and so this inequality can be written in 2 ways. I like to use the double because it, I think, is pretty intuitive. Basically, all the numbers between -4 and 2 is what we're trying to describe. You could also separate it into 2 parts. If you did that, this would be all the numbers that are greater than -4 and at the same time less than 2. Or less than or equal to 2. Okay, so the and is kind of important because that means that we're going to satisfy both of those inequalities at the same time. So when we draw this, we want to think about the numbers not including but greater than -4. So I'll start my line segment shading that way. Okay, and at the same time I want my shaded region to also be less than or equal to 2. So we end up with numbers that are in between. And if we want to describe these with interval notation, right, I'm not including -4 itself, so I use the round parentheses for that. But I am going all the way up to 2, and the 2 is included because it's less than or equal to, and so I use the square bracket on the right. I hope this gave you a pretty thorough idea of what interval notation is. This is something we use a lot in college algebra. This is something that we're going to build upon and use as a tool in a lot of different areas. So it's a really good skill to get under your belt right here at the beginning of the course. All right, good luck. Thanks.